side. On the production side, you've got 3 different types of solar systems that we commonly use: grid-tie solar electric, PVT, which stands for photovoltaic and thermal, kind of a combo system, and then you've got solar thermal systems. And we use them all. Mainly it's been grid-tie solar electric, a few PVT, and a few solar thermal. So at any rate, so we work on the reduction, we work on the production, and then we have a way. It's easy to calculate how many kilowatt hours a year are required for domestic hot water, space heating, and air conditioning. It's a little bit harder to calculate for lighting and appliances and other usage, but we have a methodology we'll show you here in a second. We think it works out pretty good. So once we've calculated the kilowatt hours required, it's then very easy to design or size a solar system to provide that many kilowatt hours on an annual basis. The goal over the course of the year is to have a net zero energy house, a house, again, that produces the same amount of energy as it uses. Okay, so why is it important to have a net zero energy house? Well, the Public Utilities Commission has determined that half of all new homes built in 2016 need to be net zero energy. By 2020, all new homes in California, unless there's a building in the road, building in the way, trees in the way, or a mountain in the way, will be net zero energy. There's also 9 million existing owner-occupied single-family homes that, with some really amazing financing that's going to be available to these homes to make them more efficient. The AB 811 program, which is going online in it's already online in some communities, and by later this summer, later this year, will be online in many more. It's a way to have an assessment to your property taxes to pay for energy efficiency improvements, better lights, better appliances, better insulation, more efficient HVAC, as well as solar to to fire the whole thing. The other thing is, California is perfect for net zero energy houses. For the most part, a mild climate, abundant sunshine, and also in 2010, feed-in tariffs kick in. So if we do overshoot slightly, there's a way to get some of that investment back. But all these make for a very enticing program. But the basics of all this is that it turns out it's very, very cost effective right now. In 2009, when we did the 100 houses, none of those people had to do it. They all chose to do it because it was cost effective, or for other reasons they felt it was very compelling. Okay, the downside to using electricity and to do these homes mostly all electric is our electric rates in California are unbelievably high, especially if you're in one of the investor-owned utilities, PG&E, Edison, or San Diego Gas and Electric. You're paying a fortune. What this chart does is it compares the cost of electricity on a BTU for BTU basis with a cost of gasoline. My assumptions are gasoline's at $3. There's 125,000 BTUs in a gallon of gasoline, 3,412 BTUs in a kilowatt hour of electricity. Natural gas is 100,000 BTUs in a therm. Propane, 92,000 gallons per gallon. I got propane at $3 a gallon and natural gas at $1.30 a therm. At any rate, the way your PG&E bills work, for most of you in Northern California, is you have 5 tiers. The first tier is if you have a very small house, almost like a studio apartment, you have to use somewhere in this lower level. You pay about 12 cents a kilowatt hour. If that was gasoline, you'd be paying $4.39 a gallon, which is a pretty good deal. The problem is if you have a little bit larger house, you pay a little. The more you use, the more you pay. It's like going to get your gas tank filled up. If you have a 15-gallon tank, your first 3 gallons are charging you $4.39 a gallon. The next 3 gallons are charging you $5.12. After that, they're charging you $10 a gallon, and then $15, and then $17. Most new homes have you're buying a lot of electricity at these upper rates, and it gets very, very expensive. And see, we have the choice. We have to buy electricity to do lights and appliances, to do air conditioning, to do well pumping, and that sort of thing. We have to use electricity. We don't have to use electricity to do space heating. And but at the same point, there's compelling reasons to do so, and we'll go through that in a second. Okay, now some of you may be in areas that have much lower rates. This is for LA Department of Water and Power. There's a lot of municipal utility districts that have lower rates. SMUD up in Sacramento, I think Palo Alto has its own utility, a few other areas also. And these rates are much less. And if you're Department of Water and Power, you're paying 12 cents a kilowatt all winter long, or the equivalent of $4.54 a gallon. And so I think the average cost in California is around 18 cents, but that's average. I would say, again, most of the new homes they end up using, they can be charged a lot more for that. Okay, so let's just talk about reduction for a second. Again, these are things that are already being done on almost every new house. Better insulation, significantly better windows. ENERGY STAR windows have become very much of a standard, and there's not much of an additional cost for it, if any. I mean, Milgard sells their ENERGY STAR windows for, I think, 2 cents more a square feet or something. It's almost insignificant. Also, there's now a requirement in California to have ventilation for all new homes. The thought being the houses are so much tighter than they used to be. You need to supply some fresh air. Some of that's being done with continuous running bathroom fans, that sort of thing, which is not a great solution. But most of the ones we're doing, we're putting in a small heat recovery ventilator, which exchanges some of the warm indoor air with fresh outdoor air. It gives up its heat, supplies a certain amount of fresh air to kind of pressurize the house, and it's a very, very efficient way of doing it. And we also know, based on blower door tests and such, exactly what the infiltration rates are, so we can fine-tune the heating design. So again, the better insulation, the better windows and all is already being done. Same thing with lighting. In most new homes now, well, I mean, to meet Title 24, you have to have half your installed wattage in your kitchen being fluorescent or LED or something high efficacy. And the way the requirements are, either the control is better by occupancy or different or timer sensors, or they just put in more efficient lighting. The basic numbers are this: compact fluorescents are 4 times as efficient in terms of your lumens per watt than incandescent, and LED, which is about the same as compact fluorescent now, but they're expecting much better as time goes on. And I think Philips has announced that later this year they're going to have a 110 lumen per watt fixture. And the price is also coming down. The light quality is great, so I think we're going to see a lot more of that in the near term. Appliances, I mean, this is a story that, I mean, normally